This model is a result of a request of a customer that wanted to see how different percentage of types of known types of marketing sales guys in his company will bring the most value to his company. And this model is using the base idea of farmers, shepherds, warriors, and hunters. In a nutshell, the idea is that farmers are keeping customers, but they are not creating any new features. Hunters will keep customers, but will create new features. Shepherd will keep customers, but will create new customers but keep the features. And warriors will add customers and will add features. And what this model is doing is taking known interaction between those four types of sales guy. It's implementing logic that says that red will be repelled from green and green will be repelled for red. On the other end, yellow will be attract to green and blue will be attract to red. And if nearby the red and the green there are yellows or blues, then it will be, if there are yellows and blues, there will be no repulsion but no attraction. And if there will be blue or yellow, there will be some repulsion but not as strong as if there aren't any element around it. So it's actually trying to look for or trying to create balance where all the types are together in order to run smoothly the operation of marketing and sales. So that's the idea in a nutshell. What this model is doing is creating 200, and we can change the number, 200 agents or people. Right now it spread 25, 25, 25, and 25%, so quarter of each one of them. And then it will start to run the logic that I described. So randomly you will see people plotting on the screen, and then they will start to move following the repulsion or the attraction, or if there is a good combination, just will stay in the same place. And based on that, the model also will start to get what is the value for the business, and it will do it by counting how many features and how many customers will be added, following the logic that I mentioned before. So if it's going to be a red person, is going to add one feature and one customer every time, every cycle that we are going to run this model. If it's going to be a shepherd, it's going to add just a new customer. If it's going to be a hunter, it's going to add just a new feature. And if it's going to be a farmer, it's not going to add nothing. So it's simply going to plot the 200, move it, and as it's moved, every circle, as it's moved and changed, it will calculate the value of those two. Now, to make it more interesting, the value will be multiplied positively if the distance between all of those is closer, and if all the neighbors or part of the neighbors around a certain given agent will be other types than the type that he is. So that will increase sometimes significantly, unlinearly or exponentially the number of features or the number of customers. And in order to balance the model, the logic that we are going to use is that if in 10 runs, the model will exponentially grow or 10 times grow the customers or the features. Since we didn't add any people, it will penalize or balance the system by reducing quarter of the customers and quarter of the features. So that's everything in a nutshell. Let's run it and see how it works. So we will start with 25, 25, 25, 25. The idea of the model that you can set up any number of people that you want and any percentage that represent your current scenario, you can run it, you can see the result, and then you can tweak it and try to find out a better result for you. So we are going to run it for 200. And you'll see that it started randomly plotting. Now you see that the segregation start to happen. So red are repealed from green and green repealed for red, except of here that there's a good combination. It still exists. Sometimes there are one on top of the other. Instead of here, there are a good combination of different elements. All the rest are pushing aside. They are repelling red from green and green for red. Which is what kind we expect to see. On the other end, we can start to see what is the value added. And what you can see here is the number of capabilities, which is green, and the number of customers, which is blue, that actually added every time that we're running the circle, this model. And as you can see, we are running it for 100 times. So every time, all the agents will be checked against who is near. So first of all, they will move. And in some point of time, they simply reach the balance and there won't be any movement. It just stay still. But the value is going to keep on being calculated. And obviously, the changes in the beginning will have some significant effect in what you see in the end. And we will reach around 600 or 800. I think it will be 65 this time. So we managed to add 65,000 customers, and we managed to add 38,000 features. And that's what we did with this combination. Now, what the model enable you is to play around. So we can say, okay, we want to red are bringing 2, so let's increase them to 50. And since we've done that, let's change yellow to 20 and green, blue to 20. So we want actually to increase the number of customers. So we will increase yellow for 30. So we can't keep the green. We want to minimize them as much as we can. So let's say that we want them 0. So we don't want any greens. We just want to grow everything in a certain way. And now we can just run, keep this reference and run the model again. So first of all, you'll see that there aren't any green. There will be less repulsion because there's nothing to repel from. And there will be less attraction. So you see the model is kind of pretty, stays the same, almost no changes. And if we go to the value, we need to wait a little bit, but I assume that the value of this model is going to be slightly different than the model before. Just let's wait a little bit and see. And you can see here, every time that it drops, it means that in 10 runs, actually the growth was more than 10 times. And now quarter went down and quarter went down, balanced the system, and now the system is recovering and trying to grow again. Yeah, you can see that it already behaves slightly different, and there is actually, like we expected, a favorism of a little bit more of the capabilities. Since we favor the types that should increase capabilities, but we already toward the end and it's like 13,000. It will never reach the 60,000. I just want to see how much it will reach. The growth of customers started to be non-linear. So it started to be linear and not exponential, and no penalty here. And the growth of capabilities seems that start to have the same scenario, and you can see that it's going to end up around 30 worst case scenario. So although we expected this model to be much better, it's actually half better than this one in terms of the end result of the value added. So pretty simple model to run, pretty simple model to create, but enable you to put your population of hunters, warriors, shepherds, and farmers, and to play with the percentage and to see which percentage is actually going to increase or provide the best value for you as a company. That's all. I hope that that was helpful. If you want the model, feel free to contact us and we'll be happy to share it with you. Bye.